Hi everyone. Today we are going to see a problem in queuing theory. First model we will see. The first model is MM1 infinity FIFO. So MM1 is the server is one. Only one server is there to give the service. And infinity represents here infinity represents how many customers are arriving for that shop. So normally we don't know per day how many customers are there. So general we will take it as infinite customers. To solve this first model MM1 infinity FIFO model, we need some basic formulas. We will see what are the formulas that are going to be used for this type. First one, mu. So mu is equal to 1 divided by E of t, that is service rate for this problem, and rho is lambda divided by mu, and P naught, it is 1 minus rho, Pn is equal to 1 minus rho power n, and these LS, LW, LS, LQ and WS, WQ are very important. Let us see what are the formulas for this LW. So LW is nothing but average number of customers in the non-empty queues. That is LW is equal to mu divided by mu minus lambda. LS, it is lambda divided by mu minus lambda. LQ, it is lambda square divided by mu into mu minus lambda. WS, 1 divided by mu minus lambda. WQ is equal to lambda divided by mu into mu minus lambda. See here, WQ can be written as LQ divided by lambda. Similarly, WS can be written as LS divided by lambda. LQ can be written as LS divided by, LS minus rho. Similarly, LS is equal to rho divided by 1 minus rho. These formulas are called Little's formula. It is very easy to remember, so that we can solve the problem easily. Better if you know lambda value and mu value, you can use this formula to solve the problems. Okay, so these are the very basic formulas we need to solve the first model. So we'll see in one example. So see here, customers arrive at a watch repair shop according to a Poisson process at the rate of 1 per every 10 minutes, and the service is exponential random variable with mean 8 minutes. Find the average number of customers in the shop. Find the average time a customer spends in the shop. Find the average number of customers in the queue. What is the probability that the server is idle? Whenever you are getting a problem, split the problem into small parts so that we can easily identify the parameters. If you are taking the parameters correctly, then we can solve the problem very easily. First we have to, whenever the problem is given, first we have to check how many servers are there and how many customers are there. So in this problem, see here, there is no explanation for the customers. So customers arrive at a watch repair shop according to the Poisson process at the rate of 1 per every 10 minutes. The whole problem speaks about only the customers. They didn't mention how many customers are arriving in this shop. So we consider this problem as an infinite customers problem. Clear? Next, we will see about the service. Normally, imagine in a watch repair shop, how many servers will be there? Normally, one person will be available. So, see, go back to the question. The service is an exponential random variable with mean 8 minutes. So, to give a service, they are taking an average of 8 minutes. Okay, clear? So, here they are not explaining about the server. The whole problem is not about explaining how many servers are available. So by default we will take this problem as a single server problem. Okay, single server problem. So very first thing, you must know how many customers and how many servers are there to solve this problem. Clear? So afterwards we will see what is the question is. So first we need what is lambda, what is u. So normally lambda represents the arrival rate. Lambda is an arrival rate. Go back to the question. So see what is an arrival rate. So 1 per every 10 minutes. 1 per every 10 minutes. What is the meaning of this one? For every 10 minutes, one customer is approaching the shop. Okay, so that we can write this lambda as 1 divided by 10 per minute. So if you want, you can convert into an hour. So how to convert it is multiply by 60. You can convert a per minute to an hour. So that I am saying this lambda for per hour 6 customers are arriving the shop. Clear? Okay, so see here, first of all we have to calculate what is a lambda. Next we have go back to the service rate. So average service rate is given in the problem. So mean 8 minutes. We have to calculate your service rate. So mu. So per minute it will take for one person it will take 8 minutes. It is an average. So 1 divided by 8. So convert this also to an hour. Multiply this 1 by 8 into 60. We can get 15 divided by 2 per hour. So now we got what is lambda value, what is your mu value. This is the very basic thing to solve this problem. So now we got lambda and mu. Next you have to calculate what is your mu. Okay. What is your rho? Sorry, what is your rho? Rho is lambda by mu. So you got lambda is 6 and mu is 15 by 2. So that you can get lambda is equal to 4 by 5. Okay. So next we go back to your question. We have to solve what the question is. Whenever you are starting the problem, you must know what is your lambda, what is your mu and what is your rho. First you calculate and keep aside. Go back to the question. Find the average number of customers in the shop. Okay. So what the average number of customers in the shop. So in the shop, imagine in the shop there are 10 members is there. One is in service, another 9 is in the queue. So they are asking how many customers are in the shop. Okay. So that one we have to calculate. So that is LS. Okay, average number of customers in the shop. There is a question also there. See here, find the average number of customers in the queue also. For that LQ. So here average number of customers in the shop, it is LS. So LS. So what is the formula? Lambda divided by mu minus lambda is the formula to find out average number of customers in the shop. So LS is equal to 6 divided by 15 by 2 minus 6, it is equal to 4. Okay, we know already lambda value, mu value, just substitute in this formula, you can get the answer. So normally in the shop there are 4 customers in the shop. Okay, so go back to the question. Next, what is the question? Find the average time a customer spends in the shop. So clear? So this word is very, very important. In the shop or in the queue or in service, that is the difference. Okay. So here the question is find the average time a customer spends in the shop. So it is WS. Okay. Whenever the customer is waiting in the shop, the formula is WS. 1 divided by mu minus lambda. Substitute your mu value, substitute your lambda value, you can get 2 divided by 3 per hour. If you want, you can convert it into again a minute. Okay, per hour 2 by 3. Per minute it is 40 minutes. Okay, if you want, you can calculate that also. So now next part of your question is find the average number of customers in the queue. So find the average number of customers in the queue. Okay, first one we are calculating how many persons are waiting in the shop. Okay, now we are calculating how many customers are in the queue. So as I said, 10 persons are there means 1 is in service, another 9 is in queue. So here they are asking the number of customers in the queue. So leave your who is taking the service. Okay, that is LQ. LQ is equal to lambda square divided by mu into mu minus lambda. So what is the answer for this one? 16 divided by 5. So what is the last part of your question? What is the probability that the server is idle? What is the probability that the server is idle? So idle means what? There is no customers. Simply the server is sitting alone. Okay. So that is the probability the server is idle. The P, the system is empty. So 1 minus rho. So 1 minus rho is equal to 1 by 5. So clear. So here they have asked the 4 points. Find the average number of customers in the shop and average time in the customer spends in the shop and average number of customers in the queue and what is the probability that the server is idle. So for all these things we need lambda, mu and rho. If you know these 3, easily the problem is solved. So the average number of customers in the shop and in the queue represents L is LQ. Okay. So waiting time, if when you are speaking about waiting time, we can use the notation as WS or WQ. Clear? Okay. Thank you. For other problems we will see in your next videos. Thank you.